Okay, so we are starting from vectors. Just a recap. Last time we said, if I can remember very well, we said whenever we are trying to resolve a vector into x and y component, let's say we have vector a, okay, then this vector a is 20 newtons at an angle of let's say theta is 35 degrees. Resolving this vector into x and y component, we said this is going to be ax is a cos theta, so this ax will be equal to the 20 cos 35. Do you remember this? So my x component of vector a will be equal to what? Those having calculators? I don't know where I've put my calculator. Those having calculators, please help us. It can't be. It it can't be. It can't be 700. It's not possible.
16.38.
16.83.
38.
16.83 newtons.
No, 38. 38.
So if I'm trying to resolve this into y component, we said this is going to be what? It's going to be ay. Then we said it's going to be a sine theta. Ay is going to be a, it is 20 sine 35, meaning that my ay, those having calculators, please help us.
11.47.
11.47. That is the y component, and we said whenever we're trying to find the angle, it's going to be theta is going to be equal to tan inverse the ay divided by ax. Now what I want you to understand here is this. Let's say we have two vectors and then you're trying to add those two vectors. Okay, I think I mentioned something like we have the first quadrant, the second quadrant, if you can remember very well. Those who were there when I was teaching about vectors, can you remember?
Some kind of.
Kind of. Okay, so now we can solve some questions. I want us to get some questions from tutorial sheets. Vectors. I believe I've got some questions. Tutorial sheet 2 vectors. I think not this one. Okay,
Sir, before you go further, I have a question.
please you can ask.
So, concerning the theta, which is negative tan, I mean tan inverse,
Yes.
are we supposed to use the second function when finding it? Like second function, then we put the values to find it.
We use the second function. What do you mean we use the second function?
Like for me, I use a sharp calculator to calculate things. So like when I was calculating tan inverse for theta, I found 5. So I just want to confirm with others if it's correct.
At when you are finding, I still don't get your point.
All right, you said theta is equals to tan inverse, right?
Mhm.
And then you said it's ay over ax.
Yes.
So my question is, I'm trying to find the the same theta, but my question is the answer 4.5, or maybe it's not the one for those who
Oh, the theta. No, the theta is the reason why we're not finding the theta is just because we have the theta there already.
Oh, I see.
But okay. I've gotten your question, and your question is going to be answered here.
All right, sure. Thank you.
Sure. So let's answer this question. So we answer this question. So we get two questions, I think. That will be just okay. If you manage to attend math class, or if you didn't watch the recorded video, I think, or if you didn't attend the class, meaning you managed to watch the recorded video, not so. And then the math tutor was explaining something about the app. I think by now you are aware that we have got an app, right? As Transcended Institute.
Yes.
Yes, so if you want to access all the solutions for physics and the past paper question solutions and also full explanation in each topic, you have just to subscribe. And it's very, very cheap, guys. One, we are going to be having classes on Saturday and Sunday. During the week, you'll be watching the videos, and then you are going to be having the quizzes and the test. Meaning, you are going to be watching videos. You are going to make your own time. We don't want to disturb your schedule where we can say if we can just be having classes every day. Sometimes we can disturb your schedule. Maybe you want to start at 20 hours or 21 hours, maybe 17 hours, and then we tell you to say you are supposed to attend tuitions from Transcendent Institute. Now, us as Transcendent Institute, what we believe online is power. If you can ask those who are in second year, I think some of you have got some ideas. Maybe you came across any second year who was introducing you to Transcendent Institute. You can even ask them.
Yes.
The reason why we encourage you to be having online classes is one, sometimes you might be busy, you cannot attend the class. Now, if we do it physical, meaning that at that particular time, the moment when you miss the class, you'll not be able to access that class. But here, if you miss the class, even those guys who are not here, they'll be able to access this recorded class at your own free time. You get my point, eh? So you'll be able to access the videos on app at your own free time. Then Saturday, Sunday, we review, we solve tutorial sheet and some other questions. When you've got questions, those questions you need to send them during the weekends. Then we solve them. You get my point, eh? So it's just a matter of you downloading the app on Play Store. The name is Transcended Institute. You don't have to struggle yourself. We want to make your journey to be easy and interesting. Okay? So it is only, I think it's 50 kwacha, right? For those who have managed to check. I'm trying to mute this person. Okay. It's just 50 kwacha. Just 50 kwacha per month. We want to make things simple for you.
50 kwacha for all the.
No. Per month is 50 kwacha.
For all the courses.
No,
So it's only one.
it's one course per course. Sure. So let's continue, guys. We continue.
Yes.
Okay. So now the question is saying a displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is the result of three successive displacement d1 of 100 meters along the negative x-axis, d2 of 200 meters at an angle of 150 degrees above the x-axis, and a displacement d3. Find d3. Last time I didn't teach you the table components, but this is high time for me now to introduce table components. Table components, I encourage students to be using table components always because it gives you what is missing. You get my point, right? It gives you what is missing. Now here what you have to do, guys, first you have to write, what will be this now? Mute your mic, guys. Mutaka. Is it Mutaka? Mataka? Okay, thank you. So what you have to do is you need first to come up with a free body diagram. Now I explained about free body diagram and sketching. There's a difference between sketching and free body diagram. For those who subscribed, I think yesterday or today, if you manage to watch the videos on app, I think you can know now the difference between sketching and free body diagram. That is very, very important. There's a difference between sketching and free body diagram. Okay? So if they ask you to sketch and free body diagram, those are two different things. So here we are going to sketch. No, sorry. We are going to come up with a free body diagram. Okay, so here is going to be our free body diagram. I'm going to use XY plane. So this is our XY plane. So we have got a vector, which is the displacement. That displacement is as a result of three vectors. They added D1, they added D2, they added D3. Then they came up with the capital letter D. Okay, so now we want to come up with these. We don't know what D3 is. That is what we want to find. You understand, right?
Yes.
Yeah. So now what we're going to do now is this. We're going to start with the same D, the same displacement which we have. Okay, so this displacement which we have, guys, we can put it here. It's 100. So it is 37 degrees above x-axis. Do you think this 37 is in first quadrant, second, third, or fourth quadrant? It is in first quadrant. You are not responding, Kyrie. So it is in first quadrant. So this is 37 degrees, and this is my D. Next, they are saying that we also have D1, which is 100 meters along negative x-axis. So if they say along negative x-axis, what is the angle? Come on, guys.
180.
180. So this is D1, which is 100 meters. Also this one is 100 meters. Next we have D2, which is 200 meters at an angle of 150 above x-axis. In which quadrant can we find 150? Remember, when we are dealing with vectors, we always get the angles from positive x-axis until we touch the vector. That is very, very important. Okay, what else? We need to know where D2 is. It is 200 meters at an angle of 150 degrees. So where can you find 150 degrees? In the second quadrant. So you are not accurate because we are just coming up with a free body diagram and no one is going to penalize you. So you can just put it here. Say that is vector D2, which is a 200 meters. So the angle from here all the way to this point is what? Is 150. So now we are saying that is the angle which we have. Now we want to find D3. D3 we don't know. They are saying that if you add D1 plus D2 plus D3 plus D3, we are going to come up with the capital D. But we have the D, it's more like it's the same as you have. We have 2 plus x is equal to 5. Find the value of x. That is what is happening there. You get it? Huh? So now here what we are going to do, guys, is this. We are going to use what we call the table components. Table components, what I want you to understand is that you are going to come up with a table. I'm going to have this. Okay. Then I'm going to have also this here. So here I'm going to put the vectors. Then this is going to have x component. This is going to have y component. Then this is going to have theta. So I'm going to put this now. Okay, then what I'm going to do now is I'm going to say this is going to be vector. I'm going to write vector here. Then here I'm going to write x component. I'll just write this. Here I'm going to write y component. Here I'm going to write theta. Okay, so we have got vector A. I don't know if you can remember vector A. No, we don't have vector A. We have vector D1. I don't know if you can remember D1. D1 is 100 meters at an angle of what? Those who can remember, what's the angle? What is the angle? 100 meters. Are you getting me, guys? What's the angle?
67.
Are you sure? This is D1. Negative x-axis
180.
180. So the angle I'm going to put here 180, meaning that the moment when I put 180 here, it's going to be very much easy for me here now to start working out. So I'm going to say that d1x is going to be, I want to find the x component of d1. It's going to be d1 cos theta. Since I have the here and I have the d1, it's just a matter of me plugging in the values. So I'm going to say that I have d1 is 100 cos 180. Those having calculators, cos 180 it should be negative. I think it's negative 100, right?
Yes.
Negative 100. You even put the units, it's in meters. I'm done with this one. I'll go to d1y. So it's going to be d1 sine theta. So d1y is going to be equal to, I have 100 sine 180. So what is my d1y? 0. After doing this, you have to cross. Here I'm going to cross. I'm going to do this. I'm done with this one. Next, I'll go to d2. So I'm going to say my d2 here. This is going to be my d2. What is our d2, guys? Our d2 is 200 at an angle of 150. So I'll come here, 200 meters at an angle of 150 degrees. So I'm going to say this is going to give me d2x is going to be equal to d2 cos theta. d2x is going to be a 200 cos 150. Those having calculators, please help me. I don't have a calculator here.
Negative 173.20.
Negative 173.20 meters. Let's go to y. We go to y. So we are going to have d2y is going to be equal to d2 sine theta. d2y is going to be equal to a 200 sine 150. So those having calculators, you can help me again. 100 meters. I'm done with this. I'm going to cross. Next, I'll go to what? I'll go to d3. d3 is the one we are trying to find. We don't know. So even here, d3x, we don't know. Even here, d3y, we don't know. Even the angle, we don't know. I'll cross. Have you seen that this is simple, right? You just follow what is there, guys. That's all. So I'll cross since I don't know. Next, I'll come to the resultant. They are saying that if we add d1, d2, and d3, the result is d, the capital D. So since D we have been given everything, I'm going to say that my D, I'm going to put it here. I'm going to say that my capital D is 100. We have been given that is 100. In case you have not seen it, this is the 100 I'm talking about. here. So they're saying at an angle of 37. So that's what we're going to do. We're going to put in. So this is going to be d x is going to be equal to d cos theta. The angle is 37. Allow me to just shift this a bit, just like this, and then allow me to do this as well. Okay, so now I have dx is going to be equal to 100 cos 37. Those having calculators, please help us. 79.86 meters. Let's go to dy. It's going to be d sine theta. Dy is going to be 100 sine 37. What will be our dy?
60.18.
60.18. 60.18. Okay, so it's also in meters. This is what we call the table component. This table component is going to give you the instinct to say, I have got the missing variables here. I don't have the dx, the d3x, I don't have the dyx, I also don't have the theta. I need to find this. That's when I can find the d3. The question is, find d3. Remember, a vector can't stand alone without the magnitude. So we need to find, sorry, without the direction. We need to find the magnitude and the direction. So it's just a matter of us adding the x components alone and the y components alone. Then we find the missing variables. Simple. They're saying that d is as a result of three successive displacement. d1, which is 100 meters along the negative x-axis. So negative x-axis, it is here, guys. This is negative x-axis, meaning that that is where our vector lies. So this is vector d1, which is 100 meters. So the angle, we have said that if it is moving toward negative x-axis, sometimes they can tell you to say it is moving toward the west. Toward the west and toward negative x-axis, it is the same thing, meaning the angle is 180. D2, it is 200 meters at an angle of 150. 150 is found in the second quadrant. That is the reason why we say that this is going to be here. So the angle from here all the way until it touches this line, that is 150 degrees. As simple as that. So this is our D2, which is 200 meters. But we don't know D3. We are trying to find I can't indicate D3 in the XY plane because I don't know where D3 is. You understand now? You understand now? Yes, now. So now from there, guys, I said we need to get this information. We put it in what? We put it in what? The table component. This is the table component which you have just. So now I was asking you to say, I believe no one is behind in terms of how to come up with the table component. When you're trying to resolve any vector into x component, we need to use cos. Y component, we need to use sine. So this is what we call the table component. Now, what you need to do is you need to add the x components alone, the y components alone, and then you are going to see what is missing. What is missing is what we are going to find. Yes, now. So what we are going to do now is this. I'm going to come here and say, since we are dealing with D, I'm going to say that. Yes, please, you can ask.
How did you find 100 meters for D1?
You mean this 100 meters?
Yes.
D1 of 100 meters, we have not found anything, we have just gotten it from the question. Have you seen? The one who was asking? Have you seen?
Yes, I've seen.
So we can continue. So what we're going to do is we're going to add these now. We're going to say d1x plus d1 d2x plus d3x. When we add these, we are supposed to get capital Dx. You get my point, eh? Meaning that,
Where is the capital X coming from?
bros, this is the capital D. This is the capital. Now this D, we have resolved it into x and y component. It is here. So the dx which I'm talking about, it is this one. Have you seen? So now I need to add this. If I add the dx, let me use different color. If I add this guy, I add this, I also add this. The result which I'm going to get is going to be this. You have seen, huh?
Now we have that you have found already the DX and Shanya. So
Yes, Kaidi, we have already found. But we don't know the D3. We want to find the D3x.
how did you find?
It's here.
Okay, continue face. Okay.
You are confused already. You have just given up to ask. Okay, anyway, you understand. Now, here, what I'm going to do is, what is our D1x? Our D1x is here, which is negative 100 meters. So I'm going to put negative 100 meters plus, what is our D2x? Negative 173. Negative 173 point what? 0.220. What is our D? This one we don't know, is the one we are trying to find. What is our dx? The capital dx? 79.86. 79.86. Now we can add those. Then we find the missing variables. So it's going to be negative what? Negative 273, right? Negative 273.2 plus d3x is going to be equal to 79.83. Not so? Huh? I'll shift this to the right hand side so that I remain with only d3x is going to be 79.83 plus 273.20. So what will be our d3x? Hmm? 273. What's your answer? Are you sure? I'm finding 353.03 meters. Okay. Now from here we can now find, I can get rid of this to create space.
But the question is
Yeah.
this 79.86 or 79.8?
Oh, it's supposed to be 3. It's supposed to be 79.83. Meaning, what's the answer?
Or
6, not 3.
okay.
So what's the answer now? If I put 6 here, what's the answer? Guys, just to tell me the answer. 79.83 0.86 plus 273.2. I'm getting the same. I'm getting 353.06.
It's the same.
So what I'm going to do now is I'm going to get this. I'm going to get this. I put it there. Let's find d3y. Now I want to add the y components, meaning that we are going to say that d1y plus d2y plus d3y has to be equal to the capital dy. So what is our d1y? Our d1y is 0. The d2y is 100. So this is 0 plus 100 plus d3 is the one we are trying to find, is equal to this one, 60.81. 60.81, meaning that this is going to be d3y is going to be equal to 60.81 minus 100. What are we going to find?
Negative 39.19.
Negative 39.19 meters. So I have my d3y to be equal to negative 39.19 meters. My goal is to find the magnitude and the direction for this. Remember, if you have your dx and or if you have the x component and the y component, meaning I'm supposed to say it's going to be d3, I put the arrow, is going to be equal to the capital letter d3x squared plus d3y squared. We know this, right?
Isn't that formula from first?
Sorry, what are you saying, sir?
That's the formula where you've introduced the square roots. Where is it coming from?
From Pythagoras theorem, sir. If I have this, if I have the theta here, this is the Pythagoras theorem. Let's say this is C, this is A, this is B. So I'm trying to find C. C, we know that it's going to be C squared is equal to A squared plus B squared, not so. So C, to find the value of C, is going to be the square root. I've introduced square root both sides, A squared plus B squared. So this is the x which we are talking about, this is the y which we are talking about. We are trying to find the hypotenuse. So that's where the formula is coming from, sir.
I get your point. I get.
Okay. So now, from here we can find the d3y. d3, what will be our d3? Those having calculators? It's going to be 356.03 okay, then we square it plus, you can ignore the negative because that negative is going to be cancelled because it is squared. So you can say 39.19 squared. What are you getting?
Sir, here it's not supposed to be 356. I guess it's supposed to be
353. 353. Sorry. So 353.03 squared.
Sir, before you go any further,
Sure.
whenever you encounter this question, you are supposed to use this method.
You mean the table components?
No, not the table component. But
You mean
doing this?
yes,
and finding
yes. As long as you are finding the magnitude, any vector, this is where it's going to take you. You need first to find the x component and the y component, then you need to use this Pythagoras theorem. Any
So here
vector,
we're finding
the magnitude, yes, and not the direction.
direction.
not the direction. We're finding the magnitude only. To find the direction, I'm going to show you how we find the direction.
Okay.
Sure. So what are you getting? I'm getting 355.22, which is the same as 23 if I round it off meters. That is my magnitude. What are you finding?
355.2.
Now, okay. Now, how do you get to find? Okay, I get it. Your network is breaking. Your network is not. So we have found now the magnitude. Aye, aye, aye. We have now found the magnitude. We want to find the direction. To find the direction, we always.
Sir, before you proceed, I have a question.
Yes, yes.
How do you know that? How can you tell that the question is telling you to find the magnitude and the direction?
Nice question. Have you seen the question is saying find D3?
Yes.
Yes. So find D3. We are talking about this question is under vectors. So the moment when they say find D3, it is they want you to find vector D3. Now you know that a vector is a physical quantity which has got both magnitude and direction. Meaning that we need to find the direction and the magnitude because it's a vector.
Okay.
You get my point, eh?
Yes.
Yes. Sometimes they are going to, okay, since we are still solving some questions, we are going to see some other questions where they are going to be telling you to say, find the magnitude and direction. But in most cases, they are going just to tell you to say, find the vector D3. You know that it's a vector, meaning it's supposed to have a magnitude and direction.
Oh yeah.
Yes. You get it, right?
Yes.
Sure. So now, how do we get to find the direction? This is what you do. So allow me to get rid of this first, because I no longer need this. What I'm going to do now is I'm going to shift this a bit. I'm going to shift this a bit. I put it here. Remember, we said theta is equal to tan inverse. So it's going to be d3y divided by d3x. That is the y component divided by what? The x component. Now, what you do is, before you find the angle, for those who were there when I was introducing vectors, I think you got the point. If there is anyone who was there, what did I say before you find the direction? Or if you have been watching my videos, before you find the angle, what do you do first? You all don't have an idea. Yes.
We've got to take a question. First, why are you getting this tan inverse and the dy over dx? Ashan?
You've got a question or you're answering my question?
It's a question. It's a question.
What's your question, sir?
As why are you getting this tan inverse this formula here what you have written?
Okay, so this is the formula on how to find, when you are trying to find the direction, it is given by theta is equal to tan inverse the y component divided by the x component. I explained how this formula is coming about. If you are not there, you should remind me in the group. I'm going to send you the video, the recorded class which you had, because if we go back again, then we're not going to finish to solve this question. But I explained on how to come up with this formula. But even if you don't know how to come up with it, as long as you just know that it is theta is equal to tan inverse the y component divided by the x component, then you are okay. But if you are interested to know where it's coming from, and then you can watch my video because I explained about it. You get my point, right? Now I said if this is our xy plane, we said that this is negative, this is positive y, negative y, positive x, negative x. As long as you find that the x component, this dx is positive, so meaning that this is positive here, the y is negative, meaning this is negative. So where is the angle? The angle is supposed to fall in the fourth quadrant. Before you even find the angle, you'll be able to know that this angle is supposed to fall in this quadrant. So here I know that the angle is supposed to fall in the fourth quadrant. What I'm going to do is the answer which I'm going to find, the theta which I'm going to find here, I'm supposed to get 360 minus the theta which I'm going to find here. That will be my final answer. I also explained about this in the last meeting, the one we had. Okay?
Can I ask you a question, sir?
Sure.
So, since your answer is supposed to lie in the fourth quadrant,
Sure.
does it mean that your answer is supposed to be between 270 and 360? Your theta.
Your theta, no. Yes, you can think of that. Yeah, that is just okay. But the simplest way which you can do is yes, the angle is supposed to be between 270 and 360. But the simplest way is just saying 360, since you know that when you reach at this point, it's going to be 360 from here all the way to there. So it's going to be 360 minus theta. And I said, when you are plugging in the values here, you ignore the negative. Don't include negative. As simple as that. So what I'm going to do here is I'm going to say that theta is going to be tan inverse. The y component is 39. I'm going to ignore the negative. Divided by 353.03. I'm going to ignore the negative because I'm going to do minus. But if you want to include the negative, meaning you are going to add 360. But adding is going to confuse you. That's why I'm telling you that when you are plugging in the values here, ignore any negative which you see. So what answer are we going to get here? Shift tan inverse, open brackets, 39.19 divided by 353.036. I'm getting 6.33. Let me say 34. No, 33 degrees. So this is not the final answer. The final answer is going to be 360 minus 6.33. So 360 minus this one, what are we going to get? We are going to get a 353.6 degrees, which is the same as 354, right? If you round it off, it's the same as 354 degrees. So this is the answer. Why are we getting this answer? Because we are getting the angle from positive x axis until it touches the vector. So now, this 6 guys is here. Our 6 is here. This is the 6 we should have. The 6.33 degrees is here. But we want the angle from positive x axis until it touches the vector. That's why we are doing all these stuffs. Now, the magnitude is 355.23 at an angle of 354 degrees above positive x-axis. As simple as that. Unless you tell me that you have got questions.